Hey Chem Kids, Campbell here. In this video, we're going to talk about how to calculate pH and hydrogen ion concentration and a little OH. If you remember from our last video, I talked about what the pH scale was. It's just a way to tell how acidic or basic something is. The lower the pH is, the more acidic it is. And it's just an easy way to express the hydrogen ion concentration, because as you'll see when we start doing the calculations, the hydrogen ion concentration is really small. Now, if you remember in the last video, I also said that the equation for pH is it's the negative log of the hydrogen ion concentration. Well, what the heck does that mean? I mean, what's a log? Well, in math, right, the log is the base 10 number. It's the exponent of the times 10. So if you have a number like 10,000, right, if we put in scientific notation, that'd be 1 times 10 to the fourth. Because if you multiply 1 times 10 4 times, you get 10,000. So if you take the log of that number, you will get 4. So 4 is basically how many times you're multiplying by 10. We can also do this with small numbers, right? If we take the log of a small number, something less than 1, like this, 1 times 10 to the negative third, we're going to get the log is negative 3. What about if you have a number somewhere in between 1 and 0? Like here we have 6.8 times 10 to the negative 3. Well, if we take the log of that, it's going to be somewhere between 2 and 3. So all a log is basically how many times that number has either been multiplied by 10 or divided by 10. And so that's all that pH is. So when we take the pH of the hydrogen ion concentration, all we got to do is type negative log of the hydrogen ion concentration. So you may wonder why we have to put the negative in there. Well, all of our hydrogen ion concentrations are going to be really small, right? This is a small number, and we don't have negative pHs. pH goes from 0 to 14. So that's why we have to do the negative. So in your calculator, all you're going to do is you're going to type in negative, then the log button, and then the number. That's it. Now, on your calculator, I'm gonna actually do a little video clip using these calculators because this is what you have the most of. But literally, that's all you do. You press the negative, then you press the log button, and then you want to enter your number. Now, all your numbers are going to be times 10 to the something. So I recommend using your EE on your calculator, because then all you're going to have to do is type in 6.8, find that little EE button, or on some calculators it's an EXP button, and then the negative 3, and boom, you're good. When you do that, you should get 2.17. You can use, I know some of you like to use the times 10 and the caret sign. So if you do that, that's fine. Just make sure that you're in parentheses. Okay, so what you're going to do is you're going to do the negative button, and then you're going to hit the log button, which is under that second button. And then we're going to go 6.8, and then we're going to use the E button. So we're going to do second. And see, there's the EE button on this calculator. And we're going to do negative 3. We can close the parentheses. And when you do that, you should get 2.167, which rounds to 2.17. You can also use the times 10 if that's what you're used to doing. So if we do 6.8 and then we do times 10 and then the caret negative 3, close our parentheses, we should get the exact same answer. So let's do some more practice. So here are 3 different hydrogen ion concentrations. What I want you to do is pause the video, type these into your calculator, and see if you can get the correct answer. Now the first one's kind of easy, right? Because if you take the negative log of a number that's 1 times 10 to the whatever, it's just the positive of the number. So for the first one, you should have just gotten 5. Make sure you're doing negative log number. When you do the negative log of 5.2 times 10 to the negative 12th, your calculator should have spit out 11.3. Now, that's if we just write the question this way. In number 3, I have the question written more like you're going to see it in your homework packet and in your notes, or on your test. And so it'll say if the hydrochloric acid concentration is 0.05 molar, what is the pH? So again, all you're going to do is type negative log 0.05. and you should get 1.3. Hydrochloric acid is a strong acid. So when we see a strong acid, all we got to do is just negative log of the concentration of that acid, and boom, we get the pH. Okay, so now that we got that done, let's look at calculating the hydrogen ion concentration from the pH. So basically what we're going to do is we're going to go backwards. So from a mathematical standpoint, if I want to solve for H, the first thing I'm going to do is I'm going to move the negative over. Solve log of hydrogen ion concentration is equal to negative pH. So what that means then is to get the inverse of the log, right? So we can solve for hydrogen ion concentration. That's actually the 10x button in your calculator. So the 10x button is the opposite of the log. And in fact, if you look at your calculator, you will usually see that the 10x button is either like the second function of the log, or the log is the second function of the 10x button. But basically, all you do is you hit the 10x button and you do negative pH, and that's going to give you the hydrogen ion concentration. So easy peasy, right? So let's do this. So in your calculator, we want to know what is the hydrogen ion concentration if I have a solution of hydrochloric acid that has a pH of 2.56. Well, what I want you to do on your calculator, hit the 10x button and then type in negative 2.56. To get the hydrogen ion concentration from pH, you simply do the opposite of the log, which is the 10x. So hit second 10x, you'll see that, and then you type in the negative of the number, which I think was 2.56. And you should get your answer, which is 0.00275. Boom. 10x button, negative 2.56 should give you an answer that's 0.00275. Or in scientific notation, it's 2.75 times 10 to the negative third. Again, this is a concentration, so you need the big M for molar. Now, whether you put it in scientific notation or not is totally up to you. It doesn't matter to me. Sometimes it makes more sense to put it in scientific notation, as you'll see on our next slide. All right, I want you to try this. So in your calculator, 10x button, negative 4. 10x button, negative 2.3. 10x button, negative 14.5. 14.5, that seems a little high. Well, if you did that right, for 4, you should get 0.001 molar, or 1 times 10 to the negative fourth. Again, scientific notation or not, it's up to you. Here's what you get for 2.3. And for 14.5, you should have gotten 3.16 times 10 to the negative 15. Now, one thing, if you're not putting it, when you hit the 10x button, if you don't do negative pH, you will get the opposite signs. So if you don't put negative 4 in, you're going to get 10,000, not 0.0001. Same thing, if you didn't put in the negative 2.3, you would get 5 times 10 to the third, or 5,000. So make sure you put in the negative, because we need to reverse the log on the reverse the sign on the exponent. All right, last thing, pH from the OH concentration. So sometimes we're going to give you the hydroxide ion concentration, and we're going to ask you for pH. So pH, remember, is the negative log of the hydrogen ion concentration. So what do we do if we get OH? Well, this formula you need to write down. You may want to highlight it. The POH plus pH equals 14. That means if we can find the POH, all we got to do is subtract that from 14, and we're going to get pH, because POH and pH are opposites of each other. So this is what you're going to do. If you're given a hydroxide ion concentration, you're going to do what we would normally do to calculate pH. So you're just going to do negative log of the OH concentration. That's going to give you the POH. Then all you got to do is take 14 and subtract that number that you just got, and that will give you the pH. So not bad, right? So let's do this. What is the pH of a 0.006 molar solution of sodium hydroxide? So notice this is sodium hydroxide, which is a strong base. So that means that this 0.006 molar is the concentration of OH. So first thing you're going to do in your calculator, type negative log 0.006. That should give you 2.22. Then you just got to subtract that from 14 and boom, you get the pH, which is 11.78. Does it make sense that a solution of sodium hydroxide, which is a strong base, has a pH above 7? It should. All right, try this one more time. What is the pH of a 1.5 times 10 to the negative fourth molar solution of potassium hydroxide? Again, strong base, so that means that's the concentration of hydroxide. If you got 10.17, you are correct. All right, work on the problems in your packet. Let me know if you have any questions.